Hello everyone. I welcome you all for the e-video prepared for unannounced syllabus under the regulation 2021. Today we are going to see the topic on CPU scheduling from the second unit process management in the course CS 3451 Introduction to Operating System. The objective of today's session is to know about the basic concepts of CPU scheduling and the session outcome. The students may be able to understand the basic concepts of CPU scheduling. Let's have an overview of today's session. First, we'll be discussing about what is meant by a scheduler and what are the types of scheduling involved. There are two types. One is preemptive scheduling and the second one is non-preemptive scheduling. And next, we'll be seeing about CPU scheduling and CPU utilization and CPU burst and IO burst cycle. Next, we'll be seeing about the CPU scheduler, that is otherwise called as short-term scheduling. First, let us have a look for what is meant by a scheduler. A process scheduler which will perform the scheduling activity, that is, which will schedule different processes to be assigned to the CPU. This assigning activity will be based on particular scheduling algorithms. So this is the task of the process scheduler. The process scheduler will assign some processes to the processor, that is CPU, based on the scheduling algorithm. So next, we'll be seeing about a CPU scheduler. That is, whenever the CPU becomes idle, the operating system will select one of the processors in the ready queue to be executed. So this is the task of the CPU scheduler. The selection process will be carried out by the short-term scheduler, which is otherwise called a CPU scheduler. The scheduler will select the process from the processes in the memory that are ready to execute and will allocate the CPU to that process. So dispatcher is nothing but a module that gives control of the CPU to the process selected by the short-term scheduler. So dispatcher, that is, we can also see the dispatch latency, which is defined as the time taken for the dispatcher to stop one process and start the another process running is known as dispatch latency. We can divide the scheduling process into two types. One is non-preemptive scheduling, the other one is preemptive scheduling. We'll see about non-preemptive scheduling. So once the CPU is assigned to any one of the process, the process keeps the CPU until it released the CPU either by termination or an IO event occur. So CPU will be assigned to any one of the process. So this process will keep the CPU until it has been released by any one of the other process by termination or an IO event occur. Next, we'll say about the preemptive scheduling is based on the priority. So where a scheduler may preempt a low priority running process anytime when a high priority process enters into a ready state. That is, so always the preemptive scheduling will be carried out based on the priority. So whichever the process has the high priority, that will enter into the ready state. And whichever the process has low priority, so that will be preempted for some time. Next, we'll see about the CPU scheduling. The major task of an operating system is to manage a collection of processes. In some cases, a single process may consist of a set of individual threads. In both situations, a system with a single CPU or a multi-process system with a fewer CPU than processor has to divide the CPU time among the different processes or threads that are competing to use it. That is, this process is called as CPU scheduling. So CPU scheduling means the operating system has to divide the CPU time among the different processes or threads that are competing to use it. What are the objectives of a scheduling? We'll see. Here, some of the objectives are listed here. The first objective is to maximize the CPU utilization. If you are proceeding with the CPU scheduling, you can have the maximized CPU utilization. That is, always the processor will be kept busy. Okay, next, maximizing the utilization of the other resources and need to maximize the throughput. Throughput is defined as the number of jobs completed per unit time. And we need to minimize the waiting time. So waiting time is nothing but the total time taken for a job that spends waiting for a resource to available. Next, minimize the turnaround time. Turnaround time is defined as the waiting time plus the computation time plus the I/O time. So the summation of all these will be getting the turnaround time. Next, minimizing the response time also. So response time is defined as the time taken from entry of the command until the first output starts to appear. Next, CPU scheduling will also provide fairness, that is, all comparable process or job should be treated equally. Every job or every process should be treated equally. So CPU scheduling is the basis of multi-programmed operating system. So as we have seen already, operating system can be of two types. One is multi-programmed operating system, the other one is time-sharing operating system. So by switching among CPU among processes, the operating system can make the computer more productive. So if you switch, the process can be switched among the processes, CPU. So thus we can increase the utilization of the processor. In a single process system, only one process can run at a time. Any other processes must wait until the CPU gets free and can be rescheduled. The objective of the multi-programming is to have some process running at all the time. That is, some process need to be run at all the times. That is, the CPU will be busy at all the times. It never kept idle. So which will maximize the CPU utilization. A process is executed until it must wait, typically for the completion of some I/O request. If the I/O request is made, the process needs to wait. So in a simple computer system, CPU can just sit idle if an I/O request is made, and then waiting time is wasted. No useful work is accomplished or performed. So this is in case of a single processor operating system. So all of them is the waiting time is wasted, no work is done, useful work is done. If you move on with the multi-programming operating system, we try to use the time in a productive manner. Several processes will be there, it will be kept in memory at one time. When one process has to wait, the operating system takes the CPU away from that process and gives the CPU to another process, and this pattern continues. So one of the four circumstances can occur when a process switches from running state to the waiting state. Second situation is when a process switches from running state to ready state. For example, when an interrupt occurs, it moves from running state to ready state. Then when a process switches from the waiting state to the ready state, for example, at the completion of the IO. Fourth case, when a process terminates. So for the situation 1 and 4, there is no choice of scheduling. Only the scheduling occurs when it is in the second case and the third case. So if any new process exists in the ready queue, it must be selected for the execution. However, there is a choice of moving with the second situation or third situation. When scheduling takes place only under the circumstance of 1 and 4, we say that the scheduling scheme is non-preemptive or otherwise called as cooperative scheduling. Otherwise, it will be a preemptive scheduling. Non-preemptive scheduling. In a non-preemptive mode, once if a process enters into the running state, it will start executing or continues to execute until it terminates or blocks itself to wait for the IO request or by requesting some operating system service. So until the IO request, the process receives the IO request, will continue to execute until it terminates. Preemptive scheduling means in a preemptive mode, the current running process may be interrupted and it may move to the from ready state to the it will move on to the ready state. So from running state, it will move on to the ready state when it gets interrupted. The interruption will be carried out by the operating system. Here you can see the state diagram where you can see the process states, 5 states are there. Each process may be in any one of the 5 states: new state, ready state, waiting, running, and terminated. In a single processor unit, only one process can run at a time. Others will be waiting until the CPU gets free and it can be rescheduled. The objective of the multi-programming is that some process will be running at all the times, which makes the CPU utilization in a maximized manner. A process may require IO request during execution. If the process receives the IO request, then it has to wait for the completion of the IO request. And when an interrupt occurs, also immediately the CPU will be assigned for the another process. This pattern continues. The CPU scheduling is central to the operating system design. Here you can see the CPU burst cycle and IO burst cycle in this picture. So the process execution will be combining a cycle of CPU execution and IO wait. So the process execution begins with the CPU burst. CPU burst means the time taken to complete the CPU execution. So this CPU burst is followed by the IO burst. So IO burst means it's the time taken for completing the IO request, which is followed by another CPU burst, then another IO burst, and so on. The final CPU burst ends with the system request to terminate the execution. So once the process execution starts, it begins with the CPU burst. And if the IO request, if the process receives the IO request, then it needs to wait until the IO request is completed. So once the load the store command, add the store command, and read from the file which will be processed. And it has to wait for the IO request to be completed. Store the increment process, then index value will be written to the file, and again has to wait for the another IO request. It goes on. The process continues. The final CPU burst ends with the system request to terminate the execution. Next, we'll see about the CPU scheduler, that is short-term scheduler. Whenever CPU becomes idle, the operating system must select one of the processes which is stored in the ready queue or which is placed in the ready queue to be executed. So this selection process is carried out by the CPU scheduler, otherwise called as short-term scheduler. A ready queue can be implemented using the various scheduling algorithms like first in, first out queue, a priority queue, a tree, or simply an unordered linked list. The records in the queue are generally process control blocks of the processes. So all the information will be recorded in the queue. That information will be stored or saved in the process control block. It is in the PCB. These were the references used for preparing the slides. Thanks for watching. Thank you.